shape, size, and dimension. Now, looking at these few pictures, what can you guys understand? Now, when you all see this picture, what do you think? I'm sure many of you must understand various shapes on this picture, but we never see these things as a bunch of angles or few lines or just cluster of few points. When we break down all these shapes, it comes down angles, so we get lines, and in the end we have points. So, today in this session, instead of learning shapes as whole, let's learn various angles, lines and points. Objectives. At the end of this lesson, you will be able to define line, line segment, ray and angle. Differentiate between intersecting lines and non-intersecting lines. Relate between the angle formed when a ray stands on a line. Write the axioms based on pairs of angles. Prove the given theorems. Find relation between parallel lines and transversal. Prove theorems and examples related to lines parallel to the same line. Prove the angle sum property of a triangle. Basic terms and definition. We know that a part or portion of a line with two endpoints is called a line segment. The line segment AB is denoted by AB. So let's see this definition. Line segment. A part of a line with two endpoints is called as line segment. The line segment AB is denoted by AB bar. A part of a line with one endpoint is called a ray. The ray AB. So we can see the definition which is given here, and the ray AY is denoted by AY bar. So let's move on to next concept, that is collinear and non-collinear points. Points that lie on the same line are called as collinear points, and points that do not lie on the same line are called non-collinear. We also know that if three or more points lie on the same point, they are called collinear points. Here, AGF are called collinear points, and point BCE are called non-collinear points. Angles. An angle is formed when two rays originated from the same endpoint, that is, angle B or angle ABC or angle CBA. Now come to an angle. An angle is formed when two rays originated from the same endpoint. The rays making an angle are called the arms of the angle, and the endpoint is called as the vertex of the angle. So let's see this definition of the arms of the angle given here, and also see the definition of vertex of the angle given here. Types of angles: acute angle, right angle, obtuse angle, straight angle, and reflex angle. Let's go through them one by one. An angle measures between 0 degree and 90 degree is called as acute angle. An angle exactly equal to 90 degree is called right angle. An angle measures between 90 degree and 180 degree is called an obtuse angle. An angle exactly equal to 180 degree is called straight angle. An angle measures between 180 degree and 360 degree is called reflex angle. Intersecting and non-intersecting lines. Intersecting lines are lines that cross between them is called as intersecting lines. Non-intersecting lines, lines that never cross and are always the same distance apart, is called as non-intersecting lines. Pair of angles. Mainly there are so many angles, like first one is complementary angles. The sum of two angle is 90 degree. then the angles are called complementary angles. Example for angle A is equals to 30 degree, angle B is equals to 60 degree. Therefore, angle A plus angle B is equals to 30 degree plus 60 degree is equals to 90 degree. Next one is supplementary angles. The sum of two angles is 180 degree. Then the angles are called supplementary angles. Example for angle A is equals to 101 degree, angle B is equals to 79 degree. Angle A plus angle B is equals to 180 degree. Another question for you. What do we call those angles we have common vertex, a common arm, and their non-common arms are on different sides of the common arm? They are called adjacent angles. So we can see the definition of adjacent angle given here. If the non-common arms B and BC are form a line, then it will look like this. Then the angles ABD and DBC are called linear pair of angles. So we can see the definition of linear pair of angles given below. When two lines, say AB and CD, intersect each other on the point O, then the angles formed are called vertically opposite angles. Move on to next one, that is axioms. First, axiom 1. If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. Axiom 2. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angle form a line. Let's move on to theorem. Theorem 1. If two lines intersect each other, then the vertically opposite angles are equal. Let's prove this. At this statement, given that two lines intersect each other, so let AB and CD be two lines intersecting at O. The lead to two pairs vertically opposite angles, namely angle AOC and angle BOD. Angle AOD and angle BOC are vertically opposite angles. To prove angle AOC is equals to angle BOD, angle AOD is equals to angle BOC. Now ray AO stands on line CD. Therefore, degree AOC plus angle AOD is equals to 180 degree, equation 1. Similarly, angle AOD plus angle BOD is equals to 180 degree. It is equation 2. Now, from equation 1 and 2, we get angle AOC plus angle AOD is equals to angle AOD plus angle BOD. And here angle AOC is equals to angle BOD. Similarly, angle AOD is equals to angle BOC. Hence, we prove this theorem. Now, examples on this theorem. Example 1. In figure, line PQ and RS intersect each other at O. If angle POR ratio angle ROQ is equals to 5:7, then find angle POR and angle ROQ. So you can see below angle SOQ is equals to angle PQR is equals to 75 degree, that is vertically opposite angle. Hence we proved parallel lines and transversal. A transversal is a line that intersects two or more lines in a plane at different points is called transversal. You can see below explanation. So let's prove this transversal theorem. Now angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. These are angle 1, angle 2, angle 7 and angle 8 are exterior angles. And angle 3, angle 4, angle 5 and angle 6 are called interior angles. We also studied that when a transversal intersect two lines, we get some pairs of angles. Let's go through them one by one. First is corresponding angles. These are angle 1 and angle 5, angle 2 and angle 6, angle 4 and angle 8, angle 3 and angle 7. Second is alternate interior angles. Those are angle 4 and angle 6, angle 3 and angle 5. Then comes alternate exterior angles, and they are angle 1 and angle 7, angle 2 and angle 8. Next is interior angles on the same side of the transversal. These are angle 4 and angle 5, angle 3 and angle 6. Next one is axioms. If a transversal intersects two parallel lines, then each pair of corresponding angles is equals. Corresponding angles axioms converses. If a transversal intersects two lines such that a pair of corresponding angle is equal, then the two lines are parallel. Does the statement holds true? Let us verify. Draw a line AD and mark point B and C. At B and C, construct ABCQ angle and angle PCS angle equal to each other. Now predict angle QP and SR. We can observe that two lines do not intersect each other. We cannot draw common perpendicular lines between them because they are different points and measure their lengths. You will find the same everywhere. Next, move on to theorem. If a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. Let us prove this theorem. Let us give one angle BQR equal to angle PQA, mark as equation 1. These are vertically opposite angles. Now angle BQR equal to angle QRC, mark it as equation 2 given here. So from equation 1 and equation 2 we get angle PQA is equals to angle QRC, corresponding angles. Therefore AB parallel to CD. These are converse of corresponding angles axiom. So we can say that if a transversal intersects two lines such that a pair of alternate interior angles is equal. So next move on to lines parallel to the same lines. First one, theorem. Lines which are parallel to the same lines are parallel to each other. Let us prove this with the help of an example. Now let us solve them examples related to parallel lines. Given that if PQ is parallel to RS, angle MXQ is equals to 135 degree and angle MYR is equals to 40 degree. Find angle XMY. For solution, we need to draw a line AB parallel to line PQ. So point M. Now AB is parallel to PQ. PQ is parallel to RS. Therefore, AB is parallel to RS because two lines are parallel to same lines. Now angle QXM plus angle XMB is equals to 180 degree. AB parallel to PQ. Interior angles on the same side of the transversal XM. But angle QXM is equals to 135 degree. So 135 degree plus angle XMB is equals to 180 degree. Therefore angle XMB is equals to 45 degree. Mark as equation 1. Now angle BMY is equals to angle MYR because AB is parallel to RS alternate angles. Therefore angle BMY is equals to 40 degree. Mark as equation 2. Now adding equation 1 and 2 we get XMB plus angle BMY is equals to 45 degree plus 40 degree. Hence angle XMY is equals to 85 degree. Now angle sum property of a triangle. Now let us move on the properties of the triangle. Now what is the sum of all the angles of a triangle? Yes, you are right. The sum of all the triangles is 180 degrees. Let us prove this statement using the axioms and theorems related to parallel lines. Property is the sum of the angle of a triangle is 180 degree. We are given a triangle PQR and angle 1, angle 2 and angle 3 are the angles of the triangle PQR. We need to prove that angle 1 plus angle 2 plus angle 3 is equals to 180 degree. Let us draw a line XPY parallel to QR, that is opposite to vertex P. Now XPY is a line. Therefore, angle 4 plus angle 1 plus angle 5 is equals to 180 degree. Mark it as 1. Now XPY is parallel to QR and PQ PR are transversal. So angle 4 is equals to angle 2 and angle 5 is equals to angle 3. Pairs of alternate angles. Now by substituting angle 4 and angle 5 in 1, we get angle 2 plus angle 1 plus angle 3 is equals to 180 degree. Or we can write as angle 1 plus angle 2 plus angle 3 is equals to 180 degree. Theorem end. Thanks for watching this video.